But right now, we're finishing our notes. Leave this out. We're going to get to it. But right now, we have to do the last two problems in our notes, which are this and this. Oh my gosh, these look frightening. But remember, we talked about yesterday how easy these problems are. So, can you look at the one above? How do we start? Do you remember? Look, see if you can make sense of your notes. Draw a picture. Draw a picture. This is X and Y right here. So we're going to draw a picture. So it would be over and down. So it would look like this. Right? Is that okay with everybody? Now, take it or leave it, but you probably should be able to tell me how big this angle is right now, just by looking at what I've drawn. See how those two are the same number? What does that mean that angle is? 45, right? Now, what if you didn't recognize that or didn't remember that? How do we technically find that angle? Not sine. Nope.
Tangent.
Second tangent. So don't we say the tangent of that angle is this, which is basically -1. And then we second tangent, right? And it'll say 45. But if you can tell just by looking, just put 45. But remember, if you can't, to find the angle, it's always second tangent, right? Okay, what else do I need?
Hypotenuse.
I need the hypotenuse, the R value. And how do I find that? How do I find the length of this guy right there? Pythagorean theorem. What do you get when you square root 2? 2. What do you get when you square this? No, you don't get negative, you get 2. 2 plus 2 is 4, and the square root of 4 is 2. So my radius is 2, and my angle is not 45. What is my actual angle? 360 minus 45, which is 315. Now, see the I in the problem? That's why I have this notation. I always have to have the CIS notation if there's an I in my problem, because it needs to have that I. Okay. All right, so that's step 1. Draw a picture, figure out your R and your theta. Perfect. Now, what does the rule say? If we have a number in polar form or trigonometric form, and we want to raise it to the 3rd power, what does de Moivre's theorem say? What do we do, Mr. Schlebecker?
You raise your first number by that power and then you multiply it.
Exactly. So we take 2 to the 3rd, which is 8. And then we take 315 times 3, which is 945. So the rule says radius to the power, angle times the power. Now, Olivia has pointed out that angle's too big. We talked about this yesterday. If you get an angle that's too big, what do? Subtract 360s, right? What if we get an angle that's too small? Add 360s, right. Okay, actually I think I can take out a couple of 360s. Does that come down to 225? And this,
Does it give me a pass?
are the outer red lanyards?
Yeah.
This is the polar form answer, or trigonometric form. You have to get used to both of those words. It's called trigonometric form or polar form. That's the answer. Now, if you also have to answer In rectangular form, which is also called complex form, is this four word or so many words for everything? I don't know. Rectangular, complex, same thing. What does that mean I need? If I want rectangular form, I need X and Y. Right, kids? So X equals what? What does X equal?
A cosine.
Exactly. R cosine 225 and Y equals R sine 225. You will have a calculator on the test. So let's just get our calculator out and type it in. What do we get for, these should both be the same number. What do we get? Negative 5.65. So our answer, they won't always match obviously, but with 225 they will. So negative 5.65 minus 5 is 0.66. So that is my rectangular form answer. You okay with that? All right, one more. Here we go. Chloe, how do we start this? What are we going to do first? This is the last problem in our notes. What do we need to do first? Draw a picture of it. So this one's over here. Okay. Now, we draw the picture so that we can find R and theta, right? So let's do our Pythagorean theorem. So 2 root 3 squared plus 2 squared. Talked about this yesterday. I'll talk about it again because it's such a shame when we miss this because we don't put it in parentheses. Whenever you are putting something into your calculator that's in two pieces, like 2 root 3, two pieces, it's got to go in parentheses. I think it's easier to not use the calculator myself. That's 4 times 3, so this is 12. If I square the 2 and square the root 3, that's 12 plus 4 is 16. So R is 4. Your calculator will give that to you. If you want to do it on your calculator, that's fine. Just make sure you're typing it in right. Now, how about this angle right here? How am I going to find that guy right there? Second tangent. Now, this is another one that's going to be a little bit tricky. You're going to second tangent 2 over 2 root 3. If you put that into your calculator, this has got to be in a separate parentheses. You might cancel and put into your calculator 1 over root 3. That's easier to put in. You see that the 2's would cancel? Calculator should say 30. You got something other than 30, you're not putting it in right. So we need to fix that. Jordan,
Yep.
What's my theta then? I know my little angle here turned out to be 30, but that's not my theta.
No, it's no 210.
210, and you got 210 because you took
180 plus
180 and added 30. That's exactly right. So your number is 4 CIS 210. And that's what you are raising to the 6th power. This problem is going to the 6th power. So the first thing we did was change it into the CIS form by finding R and theta. Now we're going to take it to the 6th. I need your help. 4 to the 6th. I I don't know what that is.
4,096.
4,096. Remember, de Moivre's theorem, our rule says we take r to the power. So 4 to the 6th. And then we take the angle times the power.
1,260.
So 1260. Now you're not going to put that in the answer blank though, because that angle is way too big, right? So let's shrink it. Just start taking out 360s. Does that come down to 180? So that is the answer that goes in the polar form answer blank. These particular directions say answer in polar, trigonometric, and complex, rectangular. So that's my polar form answer. How do I get my rectangular answer, my complex answer?
4,096 cosine.
Exactly. I need to find x and y. So 4,096 cosine 180 and 4,096 sine 180. We could do this without a calculator, but since you're going to have one, you might as well just type it in. What do we get for x? Negative 4,096. And what do we get for y?
0.
So our answer is negative 4,096 plus 0i. Remember, the I always goes with the y. Or you can just say negative 4,096. Either one, doesn't matter. Sometimes we like to add that plus 0i to just remind us that it's there, but you don't have to put it.
What's considered a good
You gotta be between 0 and 360. One revolution. All right. Oh, happy day. Let's get out our practice quests and start getting ready for that. Pre-quest. Yeah, we're gonna start it right now. We have not started it yet. We just finished our notes. So we are gonna start right now. Oh, this looks like fun. Okay, here we go. Yep, we're on number 1. Request number 1. I want you to look at the problems on this page real quick. And I want you to notice there's a similarity, let's see, between problem 1 and 4. 1 and 4 have given me an r and a theta, and they're asking me for what? The rectangular, which means x and y. So when I look at problem 1, it says convert to rectangular. That means find x and y. And what do we know about x? R cosine. So it's going to be 3 cosine 162 and 3 sine 162. Listen to me, if you are confused, rectangular means x and y. So question number 1 is saying find x and y. Question number 4 is saying find x and y. So I just type into my calculator 3 cosine 162 and 3 sine 162. And so my answer is negative 2.85, comma, 0.93. Does that look okay to everybody? Now let's go ahead and skip down to number 4. Oh, yep, Marita?
Wait, so when we add it, that's only if there's an R?
Exactly. So when we skip down to number 4, Marita, look at the directions for number 1. See how it says find rectangular coordinates? coordinates mean an ordered pair. But when I go down to number 4, it says convert to rectangular, so I'm still finding the same thing, but it doesn't say coordinates, it's got that I. So when I do number 4, x is 5 cosine 100, y is 5 sine 100. Everybody see that? Guys, when you write CIS, this is your R and this is your theta. Anytime you see the CIS. So I have 5 cosine 100, 5 sine 100. And so I get negative 0.87 plus 4.92 I. Notice number 1 was coordinates. Number 2 had an I in the problem, so it must have an I in the answer. Do you see how the math is exactly the same for these two problems?
Yeah.
The math is the same. You're finding x and y. What's different is the way you write your answer. And the way you write your answer depends on the way the problem is written. If it starts out as an ordered pair, it's going to end up as an ordered pair. If it starts out with an I, it's going to end up with an I. Okay? We good? All right. Next, let's do the middle two now. Now these say convert to polar. Now what does that mean? If I want polar, I have to find what? R and theta. So I'm starting with an x and a y, and I have to figure out R and theta. Does that picture make sense to you? What's my R?
3.
I don't understand why we struggle with this. How do we find R?
Second tangent.
It's not 7.
Square, square.
Oh, I thought it was
Guys, what's 3 squared?
I don't know.
9.
What's 4 squared?
16.
What I tell you?
When I add them together, I get 25. So my radius is 5. Okay? For Pete's sake, you're sitting there with a calculator.
Oh.
Don't put the negatives in. You're squaring. They're always going to be positive. So we get 5. That's my R. Now this is going to be my theta. Remember, your theta is always all the way around. But I'm not going to be able to find that right off the bat.
No.
I'm going to have to find this first. And how do I always find my angle? Second tangent. So this is going to be second tangent 4 over 3. I don't care if you put the negative in, it doesn't matter. I just need to know how big that angle is. 53.13. How do I find theta? 360 minus.
36.87.
So my answer is 5, 306.87. Now why did I write it with a comma? There's no I. It started out, didn't it start out as a parenthesis, as a point? Problem number 2 is a point. So the answer is going to be a point. Now problem 3 is going to be done exactly the same way. Magnus, please, keep your head up. Call me weird, but I find it disrespectful when your head's down. Are you sick? You can go to the nurse. Okay. So, problem 3. I'm finding R, I'm finding theta. I'm going to do exactly the same work over 2 up 3. What's my R? Oh, please, let's get it right this time. What's my R? Root 13. I heard somebody say it. Root 13. 4 plus 9, root 13. How do I find my theta? Right there. How do I find it? Second tangent. This one's going to be second tangent 3/2. Remember, it's always opposite over adjacent, y over x. So that is 56.31. And we're lucky this time because since it's in quadrant 1, I don't have to finagle it. It is 56, right? That's my theta. Now, how do I write my answer? Root 13. Now be careful. I'm doing polar.
Oh,
CIS 56.31. Polar form is CIS. Trigonometric form is CIS. So make a little note next to that. Polar trigonometric, that's CIS. So there's my R, there's my theta. So this is the answer to question number 3. Everybody okay? All right, let's see what's next. Convert to a polar equation. Now, we did this, but it was before spring break, so I'm sure some of you have forgotten. But these are the super simple ones. Does anybody happen to remember how to do this? It's a straight substitution. What does x equal?
1.5.
No. In broad terms, x always equals r cosine theta. X is r cosine theta. So we just put that in here. So 2 r cosine theta plus 3 r sine theta equals 1. Done. That's it. We're done. Your job was to get rid of the x and y and put in r's and thetas. So we just substitute what x and y equal. Now, as we're going through this, you should be not just writing down the answer, but making little notes. Take out the x, plug in r cosine theta. Now, this one is a little bit harder. We did these before, though. Does anyone remember how we start this problem? You will probably when I say it. You start right here. What does sine equal? Think back to your gold sheet. What's the definition of sine? Well, opposite over hypotenuse, but what is it in terms of letters? Y over r. So we're going to put y over r, get right in there in place of sine. So this could be a cosine. If it's a cosine, then we would put in x over r. It could be a tangent. We'd put in y over x. Whatever the function is, plug in its definition. Okay, now do you remember what we did next? We got rid of the fraction. Yeah, this will always be a fraction of some kind. All the functions are fractions. So you're going to have a fraction here, get rid of it. So we'll multiply by r. So we have this equation now. And then that's something special. Anybody remember what's r squared equal? No. R squared equals x squared plus y squared. So you better make a note of that. We did some of these in our notes. So you need to go back and look over that stuff. Make some notes here so you remember. And that's your equation. Oh, we just talked about this yesterday. So we're doing the multiplication and we're doing the division. Anybody remember how this works? We just talked about it yesterday, so hopefully you remember. When we multiply them, we multiply the r's and add the angles. And if that turns out too big, you shrink it, but this one's fine, 250 is fine. Remember that from yesterday? We multiply the r's and add the angles. Now, how do we do the division? We divide the r's, so that'll be 3/4, or if you want to do a decimal, 0.75. And then we subtract. Now, this is going to be a little bit of a problem because when we subtract, the angle turns out too small. So how do we handle it when it's too small? Add 360. So the final answer is going to be this. If you want full credit, that's what you have to put. As Ferris asked earlier, your angle's got to be between 0 and 360. Okay. Next. Oh, this is what we were doing at the beginning of the period. When an answer in polar form. So that's good. We only need one answer. Who remembers how to start? Draw a picture. Absolutely. It says answer in polar form. We need to find r and theta. So here's my picture. Let's find r. Find r for me. Don't depress me. What is it? 2. Very good. Because when you square 1, you get 1, and when you square root 3, you get 3, and 1 plus 3 is 4. The square root of 4 is 2. Now, some of you, awake and alert and eager to learn students, can tell me how big that is.
150.
Well,
What?
this is 30, but the actual theta is 150. You're exactly right, Ferris. Now, if I could tell this was 30 because I recognize these numbers, right? But if I didn't recognize that, how would I find that angle? Second tangent, right? So when you second tangent that, you're going to get 30. Everybody get why Ferris said it's 150?
Yeah.
So my number is 2 CIS 150. That is not the answer to the problem. Sometimes we get so excited and we think, oh, there it is, there's my polar form. But that's not the polar form of the answer. We still need to take it to the 5th power. So what does our rule say? So 2 to the 5th, which is 32. And then 150 times 5, 750. You have a calculator, type it in. That's too big, so we'll shrink it down to 30, and there is the answer to the question. Yes, James Wayne.
My calculator, when I did 150 up to like the 5th, gave me like 7.5.
Okay, but you're not doing it right.
Doing that.
What does the rule say? The rule says we take 2 to the 5th, and we take 150 times 5. So you take the angle times the power. The radius goes to the power, so it's 2 to the 5th.
So what are we dividing by to get 30?
You're not dividing by anything. You're taking out 360. Subtract 360, subtract 360.
Until you get
Until
like
you get
something
less than 360.
Okay.
So the radius goes to the power, the angle gets times by the power. All right, 150 to the fifth is a big one. All right, number 9, we're plotting points. We are not going to get freaked out. When we see a radian measure. So 2 pi over 3. Let's change that to degrees. Good review. How do we change it to degrees?
180.
Pi is 180. Divided by 3 is 60 times 2 is 120. So we're actually going to plot the point 3 comma 120. So we get our little grid going here. We find the 120 line and count out 1, 2, 3. There's point A. Negative 4 comma 60. Something like this was on your quiz. Yeah, you can't plot a negative radius. So what you have to understand is a negative R value flips you to the other side of the circle. So instead of plotting this at 60, it's going to be plotted on the other side of the circle, which is 180 degrees, right? And so we're going to plot it at 4240. So point B is plotted right there. Okay, I'm going to go ahead and graph this next one on there since I have it. R equals 5 sine 2 theta. Now, before you even graph that, you probably have an idea what it looks like. Does this equation have an R squared in it? Does it have an R squared?
Yes.
No.
No.
Well, that's your 5, that's R. Well,
Does this equation have an R squared?
yeah, you know, I messed up.
Okay, so it's not a lemniscate. Is it a spiral? No, because it has a sign. Does it have a plus or minus? No, so it's not a lima sign. The only thing left is a rose. This is a rose. The leaves are going to be 5 long, and there's going to be 4 of them, right? So let's see what that looks like. So I would suggest that your calculator's set in degrees already, I hope. And let's set up our window, and then let's leave our window alone till we get this test over with, okay? So, theta min is going to be 0. Theta max is going to be 360. Theta step is going to be 5. X min, negative, I better be safe, negative 8. X max, 8. Y min, negative 8. Y max, 8. Let's put in the equation and make sure we got a nice, beautiful picture. Did it turn out to be a rose? Did it turn out to have 4 leaves? Again, there's that weird funkiness going on in the middle. When you sketch it on your paper, make sure everything's connected. Everything should be connected even though it doesn't look like it. Let me find a color pen. So it's gonna look like this. Now Now, they don't have to be positioned exactly right, but they do, guys, have to be 5 units long. You are supposed to know that they are 5 units long. So see how I've drawn them out to the 5th circle? Make sure you connect them. Everything should be connected. Again, I don't quite understand why it's not on the calculator, but it should be. Okay? If you got issues, you know where to find me during flex, right? No, this isn't flex jail. This is flex fun. All right, now, boys and girls, I checked the clock when we started this exercise. Do you know how long it took us to get through that? 15 minutes. It took 15 minutes. With all my blabbing and everything else, it took 15 minutes. So here's what I want you to do. I want you right now, with your teammate, I want you to start practice test number 2 and see if you can get the front page done. Okay? With your teammate, see if you can do the front page. Let me turn the video off.